Want to build a strong DevOps career by mastering Kubernetes the right way? In this video, you will understand Kubernetes objects, learn how pods work, and see the practical difference between imperative and declarative deployments. So stay till the end. You'll definitely walk away with valuable concepts that every Kubernetes professional is expected to know. If you are in IT and still stuck in the same salary, not getting enough interview calls, listen carefully. Right now, there are two types of people. Those who keep waiting and those who upgrade their skills and move into high-paying roles, earning 15 to 45 plus LPA because the market has already shifted. Cloud, data, AI, DevOps. These are the roles driving real career growth today. At Coding Superstars, we have helped thousands of professionals move into top tech roles.
I got placed in IBEX Labs. Previously, my package was 8 lakhs. Now it is around 14 lakhs. Thanks for the Coding Superstar for the guidance, and the course is very worth it.
I have accepted a position as a DevOps engineer at NTI Mindtree. The skills which were taught by Coding Superstar were directly applicable to the role, and I'm confident that they will be essential for my success.
Recognized by Silicon India as one of the top 10 cloud computing training firms in India. People who once had zero coding experience are now working in top companies like Microsoft, Accenture, TCS, Infosys, and more. This is not just another course. This is your path to becoming industry ready. So watch this till the end.
So now, as I said, like we will be discussing Kubernetes objects today. Okay, if you attended the last class, there we have discussed about the Kubernetes architecture and installation. Okay, today we'll be discussing about the Kubernetes objects. So hand in hand, I'll display you the practical as well for the Kubernetes objects. And beside this, I'll be providing you one file using which you can practice this. Okay. Now, I again told you if you we'll be doing the installation once I explain you the objects also. Okay. So if you go to the portal, so every time you will be needing 3 machines to run this Kubernetes or kubeadm. So for that purpose only, just to practice down the Kubernetes objects as of now, I'll be using this environment. This is an online Kubernetes playground, okay, where there will be a control plane and there will be 2 nodes. So it's very simple. What you need to do is that you need to do this, go to that killer coda, okay, and it is a Kubernetes playground. You need to go into that. Choose your playground. You want 1 worker Linux or 2 worker Linux, whatever. And here, this is meant for practice also. If you are preparing for Kubernetes certified security analyst or Kubernetes certified administrator or Kubernetes certified Kubernetes developer also, then this environment is very helpful. Okay. You can practice here. You can open the environments for CKS, CKA, CKAD. You can practice here. This is a very important environment. So this is the single node environment. This is the multi-node environment, and it is in the latest, like 1.32. If I go to the latest one, multi-node environment, I just have to create an account. That's it. It will not charge anything. For 60 minutes, it is free. So if you see, 60-minute session is free here. Okay. If you want more, then you can take the membership. But it is very useful. So once we understand the objects, Kubernetes objects, we'll see the installation as well. So I don't want like multiple times you will create the machine, you will pay the charges. Okay. So that's why this is a free environment test. So actually there are Kubernetes objects which are responsible for the deployment in Kubernetes. Kubernetes objects. So Kubernetes objects defines the state of the cluster. State of the cluster. So there are two ways to create the object in Kubernetes. So create objects, Kubernetes objects in two ways. First is the imperative way. Imperative way. Second one is declarative way. So imperative way means using command, using kubectl command, kubectl command. Again, I explained earlier that kubectl is the command line interface for Kubernetes. So using kubectl command. Second one is declarative way, using YAML files. Now let's start with the first Kubernetes object, that is pod. So first object is pod object. Pod. So we know that running a pod means running a group of containers. Okay. So here we will be simply running a group of containers in the pod object. We talk about pod object. It is the smallest unit of deployment in Kubernetes. Smallest unit of deployment in Kubernetes. You can write like this as well, short. Okay. Then encapsulates one or more containers. It encapsulates, pod object encapsulates one or more containers. Each container represents an application or service or a microservice. Pods have their own IPs. Pods have their own IPs. Assigned from the CIDR block. Assigned from the CIDR block. Classless internet domain routing. Okay, CIDR block. Provided during the cluster setup. Provided during the cluster setup. So when the cluster is set up, cluster setup. So who provides this CIDR range? Again, I explained there is a kube proxy which allocates the IPs to the pods. Okay. Now let's create the pod. So first I'll create the pod in the imperative way. Okay. Create pods. imperative way. So first command you will be running, that you will be checking like kubectl get pods. Kubectl get pods. So it will show you the number of pods. This command will show the number of pods in the system. So there will be two columns which will be shown. One column will show total number of ready or running. One column will show total number of pods ready, running, and the containers which are the part of it, and the containers which are part of it. Then comes the commands. There will be a command called Kubernetes kubectl get pods -o wide. So it will display the wide range of information to you. It will show you, will also show the pod in which node it is placed, like this. So let's try. Okay, I'll go to the environment. Okay, kubectl get pods. So as of now, it will show you the system. As of now, you can see no resources found in the default namespace. We didn't discuss about the default and the namespace basically. So actually in Kubernetes, what happens, there are namespaces. Okay, so there is a system namespace, default namespace, like there are namespaces in the Kubernetes. Inside these namespaces, pod is running. Inside these namespaces, pod is running. Okay, we'll discuss the namespaces in detail. Okay, we'll be running the command. As of now, you can see there are no pods in the default, and whatever the pods related to application, related to services, related to microservices, remember they will only run in the default namespace or any of the custom namespace which you will create. Okay, you have to mention the namespace. They will not run on the system namespace. Okay, so there is a kube system namespace. Okay, kube release namespace. These are namespace in which system pods will be running, which are containing the files for the system. Okay, kubectl get pods. So I'll not run that -o void also, because as of now there are no pods here. We'll install something, okay, some web server, okay. kubectl run nginx. Nginx is a web server. Nginx as a pod. Nginx pod. And from where it will be running? -image. So it would have to take an image, a Docker image. So we will take that image from the Docker library. So docker.io, Docker public library. Okay. Inside the library, and inside that there will be an nginx image. I'll take this as latest, nginx latest image. Try to run this command. What it says, nginx pod created. Nginx pod created. So now if you run kubectl get pods, you can see that name nginx pod, ready 1 out of 1, study status is running, restart, we didn't perform any restart, and age is 20 seconds. So from 20 seconds this pod is running. You want more information about this pod? Then we can run kubectl describe pod. So someone asked, like, you want to know more information about the pod, then describe the pod. Okay. Describe pod nginx -pod. See, all the information about the pod is there. Okay. So name of the pod, nginx pod, namespace in which it is running, default namespace, service account, default, node, in which node it is running, node 1. What is the IP of the pod? What is the IP of the node? 172.30.2.2. Okay, this is the IP of the node. Start time, this label. So run label it is given. Okay, these are the annotations. We discussed the labels in the annotations in the coming state. Status, it is running. IP of the pod is 192.168.1.4. Okay. Container information, container ID, image, from here it is running. This is the image ID. Port and host port not displayed because we are not exposing this web server to the node as of now. Okay, we are running internally, privately. So did not expose any port over here. Started, every information, conditions, pod ready to start, container true, initialized, yes, true, ready, yes, true, container ready, yes, true, pod scheduled, yes, true. Volumes, as of now it has taken some system volume. Okay, we have not defined any volume, it's taken in. Okay, there are no config maps, config secrets. Okay, these are also objects in Kubernetes. Config maps, config secrets, volumes, we'll discuss each and every in detail, object in detail. Okay, that's why it will take some 4 to 5 classes to discuss all these objects. Okay, so this is how you can describe the pod and get the information of the pod. There is one command, kubectl top. So as of now, we did not install the API metrics here. So there is a monitoring system in the Kubernetes. Okay, you install the API metrics, it will show you, and as soon as you will run the top command, it will show you how the resource utilization is working. What is the CPU percentage which is captured by that pod in the node. Okay, everything. key performance indicators will be shown over here. Okay, so if a question arises how you will show which pod is consuming what memory, so simple answer is we will use top command. Okay, kubectl top pod. And if they will ask in which node, matrix for the node, then kubectl top nodes. So which node is consuming highest memory and CPU. Okay, like this. CPU percentage is higher. Okay. So kubectl top pod is the command. So after this, create nginx. So the command will be like kubectl run and nginx -pod use the image -image docker.io / from the library folder and the nginx latest. So this is how you will create the pod. After creating the pod, it will display like this. Okay. Like this it will display. Okay. You can also run kubectl get pods after this and more details. For more details, run kubectl describe pod. Kubectl describe pod. And which pod? The name, give the name nginx -pod. This will describe all the details. Now comes the declarative way. This was the imperative way. Okay, this was the imperative way. Now comes the declarative way. Declarative way means using YAML configuration. YAML is a configuration file. Okay, using YAML configuration. So now we have to describe the root properties. This YAML file is known as manifest file. Remember, manifest file. Okay. YAML, what is the full form of YAML? Yet another markup language. Okay. These questions can be asked. Okay. If someone wants to dig down, okay, into that, they will ask each and every question. Okay. Yet another markup language. Because like I have been asked these questions multiple times when I was like giving those interviews at that time. So very minute questions they will be asking. Okay. And with that, they will consider whether they have to proceed the interview or not. If you are not able to answer the basic questions, then they will assume that, okay, you don't know anything. So they will not proceed then. Okay. So YAML is known as manifest file. Inside the manifest file, there are root properties. So manifest file contains root properties. Root properties. What are these root properties? Let's see. First is API version. API version. You have to mention the API version. Like, see, we are calling the manifest. Somewhere in the Kubernetes system or configuration, these root properties exist. The files related to these root properties exist. So API version means we will be calling that particular API, okay, which exists with the Kubernetes, which is responsible for creation of resources inside Kubernetes. Okay. So API version. So API version depends on what object you want to create. You want to create. Whether it is a pod object or RC object or RS object or deployment object, depends. We are discussing pod object only as of now. Okay. So then you have to mention the kind. Kind is also a root property. Okay. Kind. So what kind? I am creating a pod. Okay. Or I am creating a service. Or I am creating a replica set. Or I am creating a deployment. Or I am creating a replica controller. Okay, depends. Pod. Okay. After this, we have to describe the metadata. So metadata means about the pod, information about the pod which you are creating, like name of the pod, specifications of the pod, specifications of the container inside the pod, like this. So that will contain the metadata. So data about the object. Data about the object. What data? Example, name of the pod, labels, if you want to give any labels to the pod. Okay. Labels and annotations. Okay, etc. So this will be the metadata. Then comes the specifications. Spec. So we don't write specifications, we only write spec as a part of root property. Okay, so this is also a property. Additional information about object to be created. Additional information about the object to be created. What is that additional information? Example, number of containers, name of containers, image used for containers, ports exposed. These are all the information. Okay. Additional info. So root properties revolve around these four, you can see, properties. Okay. A manifest file revolves around these four properties only. Manifest file root properties. Now let's see how to write in a declarative way. There is one more command. Before that, I'll show you. kubectl explain pod. Okay. Same work as the described one only. Okay. Not any difference. kubectl explain pod. To check the description about pod and verify the various properties like version, kind, and etc. Okay. So this is for to check the description. To check the description about the pod. About the pod and verify. Why I have to write all these things and show? Because there is no documentation which exists. Okay, I've not created one. I have to create one. I didn't get time. Okay, but to check the description about the pod and verify the various properties like version, kind, etc. And I think in this way it is more explainable what I'm doing as of now. So let's write a pod in a declarative way now. Okay, so I'll give you one example. Instead of giving an example, I'll directly write up here. Okay. So what I'll create a pod. So vi is the editor. Vi single container pod dot YAML. Now this is a file created in, since it is a shell based system, Linux system. So now before writing down anything, you have to take a permission for insert. So press an I. If you press an I, this file will come in insert mode. Okay. Now you can write or paste anything. So what I have defined here, I have to define here in the YAML file or manifest file root properties. What are those root properties? First, I have to define the API version. API version. API version. So API version used for the pod is V1. Okay, I'll use V1 here. Now I'll go to the next line. I have to define the kind. Second property is kind. What kind of object you are creating? I'm creating a pod. This is the second root property. Third root property is metadata. Metadata. Metadata means description about the pod. Okay. So you can, in this metadata, you can give the name. So name, what name we are taking here? Suppose pod with one container. Okay, suppose this is the name of the pod. Now you will describe these specifications. So inside these specifications, I will describe what? Containers. Okay, containers.
I have one question. Under metadata, can we have the labels also, right? Labels.
Everything. Labeling the pod will be coming in metadata, but like step by step, everything. As of now, I'm just explaining the basic metadata for this manifest file. Okay, a very basic manifest file. There are 8 objects in total. Everything I'll explain. Okay, don't worry. It will take some 8 classes to complete. Containers. We'll describe the container name. So coming down, name of the container. Suppose container 1. Okay. Which image is being used here? Image. So I have taken from the image from the Docker repository. As of now, the public repository I'm taking .io/nginx suppose alpine image, thumbnail of the image. Okay, this is the file created. Now I'll escape, press colon. You can see downwards, colon. W means write my file, Q means quit. So if you see on the downwards here, colon WQ, after pressing the escape from the insert mode. Okay, then press. Those who don't know the Linux part, okay, that's fine. So my file is created. Now if I see cat single, I'll see my file. So this is my file. Cat command is used to see in Linux. Okay, cat API version v1 kind pod metadata, pod with one container, specifications. Inside specification we are creating containers. What container we are getting? Name is container 1, image used is this. This is very simple manifest file. Okay, there are nothing, no annotations, no labels, nothing. Okay, now let's create it. So kubectl create -f and file name -f and file name was single container pod YAML. Pod and the name of the pod with one container is created. Now kubectl get pods. So nginx pod we created with direct command. Pod with one container we created with the manifest file. So both imperative way and declarative way, both pods are running. One is the latest image, one is with the alpine image. Okay, 2 different images we have used for nginx here.
Abhishek, I'm having one doubt. So, whenever we are creating this nginx pod, so it is running inside a container.
Yes.
So this is the container where we will deploy our front-end images.
Everything, front-end, back-end, all the microservices will be deployed under the containers inside the pods. Pod will be running multiple containers. Nodes will be running multiple pods.
So inside the Nginx container only we will deploy our front end
There
images,
are
or
many web servers in the market, not only Nginx, Apache also, any whatever is required in your organization or whatever is required by the client. According to that, whatever that is written in the documentation, according to that you will create.
no, I mean to ask, like, it is a web server, right? Nginx.
Yes.
So basically, the front end part we are deploying in the Nginx web server. So
Yes.
my question is, if suppose our web server is running inside some container, okay, Nginx, let's
Mm-hmm.
suppose Nginx.
Mm-hmm.
So I want to deploy my front end image in the
Mm-hmm.
Nginx container only, or I have to create some separate container and I have to connect the container with the Nginx container.
No, no, no,
Or
no, no. Why? See, what is an image? Actually, image is a package of source code plus dependency plus your software. So, software here is the Nginx. Okay, inside that, as of now, what Nginx I am running, this Nginx is a empty web server. Okay, there is nothing in that. Okay. So when you will combine it with the source code and the dependencies, so then those things will combine and build, and that will persist inside that image. And that image you will run it as a container. Understand what I'm saying?
okay, so in the manifest file only we have to write those things, right?
Everything will come in the manifest file. Okay.
Okay.
If we are referring any Docker file, anything, or we are creating the image, okay, as such as we will not create the image inside the manifest file, we will be directly importing the images. Creation of the image will be done earlier only. Okay.
Correct.
That we will just directly pull the image into the manifest file and we will run it as a container. That's it, nothing else. Okay. If you do get pods -o wide, it will give you the information about the pod IPs as well. See, both are running in node 1. Both are running in node 1. Okay. So 168.1.4.1.5, these are the two IPs of the two pods, two different pods. Both are running in different pods. Okay. You can also run multi-containers also. I'll show you how. Okay. So let me copy this, all the things. Part. Create pod. And then again you can run that command, kubectl get pods -o wide. Now another example I'll give you. Okay. So let me create pod with two containers. So multi-container bi multi _ containers dot YAML. Press and insert. Again, API version is v1, kind is pod, metadata pod with 2 containers. Okay, so here I'll give the name. Please maintain the indentation for the child properties. Okay, pod with 2 containers. 2 containers. Okay, this can be the name. Now coming to the specifications. Spec. Enter containers. Containers. We'll give the name for the container 1, container 1, image docker.io slash library slash nginx. I'll take this time image as run. Okay, that is the tag for that image. Second container name container 2, I don't know as of now that run tag exists or not. Okay, so maybe it get failed, but let's check. Okay, image docker.io slash library. Now we want to create something else. This time let's install a Linux system inside the container. Okay, so we'll use one image, Ubuntu 20.04. Okay, and let's run a command inside that. Okay, inside that image I want to run some command. Okay, after the Linux is installed, I'll run one command here, and that command is, suppose I want to open the shell. I want to open the shell. Bin bash. Okay, I want to open a bash shell, and then I want to execute some sleep command. Okay, or any Linux command. Okay, -c means container. Okay, inside the container let's say there is a sleep and some random number seconds. Okay, escape :wq exit cat multi-container YAML. This is the multi-container YAML we created. Okay, now you can also do one thing. If you are not confident, okay, that you should apply this file or not, okay, maybe it get fail. What you can do is that you can test with the dry run actually. Okay, so there is a dry run as well. kubectl apply. I'm just applying. Okay, I'm not creating. Applying a dry run. -dry-run. Okay. Someone has asked me this question as well. Okay. So, from the client -f file name pod with 2 containers. So what is the name? Multi-container. We'll check error parsing multi-containers, error converting YAML to JSON. Okay, so there is some error in between. Maybe in API version is okay, pod is okay, metadata, name, spec, containers, name, image, okay, command. Line 13. Which one is line 13? VL. One, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. What happened here? What issues? Press and insert. Indentation is okay. kubectl apply -f. Expected colon in the line.
You can you can validate in the camel link.
Where?
Link or paste there. And you can validate that valid or not.
Okay. Okay, inside the YAML configuration or like
No, you can copy paste this syntax in the camel link. It's pasted in the link in the chart.
Okay. Wait. Based on your amount, will tell you. Okay. Implicit key is not to be on a single line at line 12.
I think it is a indentation. Under command is a child or something.
Under command?
Under command, the bash is a child of the command, or
Yes. Maybe it needs a space. Now it is okay.
not sure. Yeah.
Weird. So let's edit it again and give some spaces. Insert, come down. I was thinking while writing down, I should give a space. Now it will work. Escape, :WQ, exit. Let's see dry run this time. Okay. Dry run, in the dry run it's created, that means it will create. kubectl, pods, -wide. Pod with 2 containers. 0 out of 2 containers are creating, status is creating as of now.
The IPs are of node, Abhishek, right? 192.
Yes.
Or it is of
Now you
containers.
can see there is an error in the image pull. Means it is not able to pull that run. I'm very much sure it is not able to pull that run. So what I'll do, I'll change it. Okay. Again, I'll use that.
Latest, right? Abhishek,
Come again.
we can take latest version, like.
Latest. That is very much okay. Everywhere.
I think the run is deprecated. I think I'm not sure.
Okay. Edit the latest only. Okay. Escape, :WQ, exit. Wait, let me delete that first. Okay. kubectl remove. Now let me create it again. Now in which one is created, another one is, I think Ubuntu one is also. This time I think if we run kubectl describe pod and pod with 2 containers. Which one is at fault? Fold created back off for this one. Kubelet. Okay. Okay, Nginx one is successfully created. Ubuntu one is not created. Okay. No issues. Ubuntu one is great, giving that error, pull back off error. Let's edit that. Ubuntu latest I can give. That will work. Instead of 20.04. Ubuntu one is not creating. I don't know why. Maybe image is not there. Again, crash loop back off. Insert. What we can take here instead of this tag, or check in the Docker IO. Let's not add any. Oh, let me start it. It is just for 60 minutes. Okay, that's why we started. So everything will be lost only. Not use any kubectl create -f. No, Ubuntu image is not working. Other one is fine. Oh, no. Okay, I'll check this, why we are not able to pull that image. Okay, let's see other part. kubectl get pods, there is one pod which still we created. One container inside the pod which we created. So now if you want to connect with that Nginx container inside the pod, then you have to perform curl and the pod IP. Okay. So if you run describe pod kubectl get pods -provide. Okay, this is the IP of the pod. If you take this IP of the pod, copy and perform a kind of a curl. Maybe curl is not installed in it. I'm not sure. Let's check. Fail to connect to container port. Okay. Now this image is also giving cache pullback. Earlier it was created with the last session. Alpine image was created. This time it is giving cache pullback. pod already exists. Here released pod Nginx. Okay, let's take this one. So here the one which we created with the Nginx one, you can see if you want to interact with that page, you can see this is the HTML page, like welcome to Nginx. Okay, this is the HTML page. The same will be displayed in the web page if you run that. Since this is not exposed to the external as of now, you cannot run it into browser, Windows browser. Okay, for that you have to expose it to the node first, and then using the node IP you can run into the browser. We'll see that as well. Okay, so this is how you can connect to the container one. Okay, now if I want to execute some commands by entering inside the shell, okay, by entering inside the shell, so how we can do that? So like in the interactive way, so kubectl exec, question will be asked, what is kubectl exec used for? Exec. Okay, so to run commands interactively inside the container, we use kubectl exec. Okay, pod with two containers. Now I want to go inside the shell, so --sh, that is shell.
Yeah, Abhishek, I think you need to use IT, interactive terminal.
Yes. Before this pod, after the pod, right?
No,
I
after
think
exec.
after exec, I think, yeah.
After exec. Hyphen IT. No.
No, correct only after container, you give a space after hyphen sh, space or dash.
Come again.
Hyphen space.
Mm-hmm.
Right.
Like this.
Yeah. Or
Default.
you can use the bash. You can use the bash bash. That will work.
Okay, instead of shell, you
Yeah, bash.
Okay. Is it okay now?
It is okay now.
Okay. Even if you mention sh also, then also like
It should be kubectl.
Mistake. By default, it will take container one, but container one is crashed, I think. That's why it is telling. So you have to give the container name also. kubectl describe -it pod name, after that -c, then the container name, then dash space sh. Then it will go inside the container.
Okay, after the pod, -c.
-c. Yeah, -c. Then the container name.
Container one, like this.
Yeah. Container one was crashed, I think. Or container two was crashed.
No, container 2 was not created due to image pullback of error. Crash loopback error. No.
You should give a container before pod.
Wait. Let us do with that Nginx one, na? Let's do with the Nginx one. That is single running. Now we don't have to mention container, right? By default.
Yeah, remove it.
Okay. Now if you give bash or sh, anyone will work. See.
Yeah.
Now you can run ls command, cat command, whatever. Okay. Tree will not work, I think. Installed. Unable to locate the package. Okay. apt-get update. apt-get install. Now it will install. Now it is giving you all the inside the container about the system. It will describe all the files and all as a tree. Okay. Now I'll exit here. Okay. This is how we can run any command interactively in the container. Okay. This is the command. Okay. If you want to mention the container from the multiple containers, then -c and the container name, and then we can do it. Okay. So this is about the pod object. Labels and selectors we'll see in the next class. Okay, already it is 10. So I think today's class is good. Okay.